This is an unmodified spindle box with the dial gauge across the face of the spindle, just to show you the error with the non-tapered bearings. I'll just zoom in on the dial so you can have a better look at that. Here is the same measurement on a modified spindle box with the taper roller bearings. I've mounted the test gauge in the same position as for the unmodified spindle box on the face of the spindle, and we can see here on the gauge the amount of wobble in that particular plane. It's considerably less than the unmodified box. It's around about 0.01 of a millimetre, about a fifth. I also did some tests to check for the degree of outer circularity in that particular plane using a dial gauge on an ER32 collet chuck holder with a 3MT spindle which fits inside the spindle, and you will see the difference between the two spindle boxes for that particular type of error. This is an original spindle box with unmodified non-taper bearings. I have mounted in it an ER32 collet holder with integral arbor, 3MT arbor. So I'll just turn that and show you the run out on that one. It's quite high. Go. This is a spindle box with tapered roller bearings, and we'll just show you the run out on that. It's quite small. This is an ER32 collet mounted on a standard X2 mill with an unmodified spindle head. As you can see, that's quite good. In the case of the mill, the spindle head is vertical and not horizontal, so those bearings, the normal bearings, seem to be reasonably good. Here we see the modified spindle with a piece of 12mm brass rod in the standard 80mm 3-jaw chuck, and we can just have a look at the error on that. You can try and reduce that error by adjusting the screws at the back of the chuck to try and get the centre of rotation variation as small as possible. You'll probably do a little bit better than that, but that's not too bad. If we spin that piece of brass up, we'll see what it's like without the gauge on it.